Now let's redo the same exact confidence interval by hand just to make sure that we're okay with that. It can't hurt. For those of you who do like doing these by hand. So the first thing that we need to do is, again, we realized that we were using z's. Let's recopy down our information. Is that we had that our sigma was given to us at 0.6. Let's see, 0.6. They also gave us our X bar sample mean, which was 1.7. They also gave us our N. Our size of our sample was 32. So I'm just recopying everything if we're doing this by hand. What else? Let's see. They also gave us our confidence level in the problem, which was, what? Let's see, 90%. So the idea, though, if I'm doing this by hand, is I need to build a confidence interval. And I need to find an upper end and a lower end. And then the question is, what goes in the middle? It's always our X bar mean, which we said was 1.7. The problem is finding the error, the thing that you're going to add to the top end and the thing that you're going to subtract on the bottom end. So we need to find an error. Because we have sigma, big deal. We had two error formulas. We're going to use the error formula with the z's in it. The error formula with the z's in it looked like the following. So we're going to use z's. So let's see. The error formula with the z's in it looked like this. It looked like the error E equals z sub c sigma over the square root of n. So we've got quite a bit of information here. Well, the sigma here, they gave it to us in the problem, was the 0.6. That'll go on top. They already have that. So we can fill in that sigma on top, that 0.6. We also know the n that we can go on the bottom, which is going to be the square root of it, though. Square root of 32. And we've already used our mean. Our mean is what's going to go in the middle of our confidence interval. We've already used that on our picture. So that's okay. The one thing that we're missing is our critical value, or z sub c, which we're going to use our confidence level to come up with that. So we need to draw our picture, just like we did in the last section. So we're going to draw our picture. Remember that we're going to use our confidence level, which was 90% or 0.90. That confidence levels are two-sided because they're based on confidence intervals. So I can fill that in. And that means my 0.90 is going to go in the middle. But in order to find the z value that's going to do this for me, I also need to know what's going to go in on the ends here. Well, if there's 0.90 in the middle, that means the other 10% or 0.10 is going to be between both ends. So 0.10 between both ends. But what does that mean about each end separately? Well, it's symmetric, meaning the same picture on both sides when you have the bell shape, so it's going to be 0.05 on each end. Splitting it in half. Now I have the picture. I need to figure out what the z value is going to be, but I still have to focus on finding the z value. Means I need an entire area to the left, which means I need to take the 0.90 and add the 0.05 from the tail, which will get me 0.95. So that means I'm going to do the inverse norm of what was on the left, which is the 0.95. Remember, to get to your inverse norm function on your calculator, you're going to hit the second distribution key, and you're going to go down to inverse norm. And let's see, what our inverse norm is going to pop out is a 1.645, and that's our Z value, our critical value. So that's what we're going to use in our formula for our Z sub C, is the 1.645. So let's make sure we do this properly according to order of operations to plug this into our calculator. I would start off by taking my 0.6 and multiplying by the 1.645. Figure out what that value is, hit enter, then divide by the square root of 32. Try to avoid rounding at any point because that will throw your answers off. So once you have that out of your calculator, you should be getting the 0.17. Now we can use that to fill in our picture. So that gave us an error of 0.17. Let's fill in our picture. So here's our interval. We said in the middle is going to go the mean, the x bar, which was 0.17. And now we have our error. We just found it. It was 0.17. So we're going to define this top end. We're going to add the error to the mean. So we'll take our 1.7, was our 1.7. I don't know why I said 0.17. 1.7 was our mean that goes in the middle. So we'll take our 1.7 and add the error, which was our 0.17, and that will get us the top end, which is 1.87. That'll be our top end of our confidence interval. And then we take our mean, our 1.7, and subtract the error, our 0.17, which gives us a total of 1.53 for our lower end. So if we were asked for our confidence interval, we would say our confidence interval for our population mean mu is going to begin at 1.53 and ends at 1.87. Remember, we put parentheses around those, but that would be our final answer. If they did ask me for the error, we did end up finding that was 0.17. And we're done. But it's a lot of work. I would say the key thing is making sure that you're showing work, and so that you can get partial credit, especially if you're doing it by hand, because it's easy to make a mistake. However, it's even easier to make a mistake in the calculator if you're not careful in how you key things in. In the